Hi everyone, so we just learned about how to solve for angles using right triangle trigonometry and that SOHCAHTOA or sine, cosine, and tangent. And now we're going to be talking about how to solve for sides using that right triangle trigonometry, same stuff. So it's really similar to the previous video. We're going to use the same ratios and all of that, but now instead of solving for theta, we're going to be solving for x. So as a quick reminder, they're going to give you an angle. Each question will give you an angle to work with, and we're going to name that angle theta, and then you label your sides opposite, hypotenuse, and adjacent based on that angle. So your opposite side is always opposite of the angle. The hypotenuse is always opposite of the right angle or the long slanty side, and then the adjacent's the side that's left over. Based on this, we can use these three formulas. Sine theta is equal to opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. That's all can be memorized with the acronym SOHCAHTOA. I'm not expecting you to memorize them. I will always give them to you on your exams and everything, but I think that you'll use them so often that at some point you might actually memorize them. So let's get started with the first example. As always, the first step is to label your sides opposite, hypotenuse, and adjacent. So in this case, they don't tell you it's theta, but they give you an angle to work with. And the first example, it's that 20 degrees. So my opposite side would be opposite of that angle, and then your hypotenuse is opposite of the right angle, and your adjacent's the one that's left over. Okay, so now that we have them labeled, what we're going to do is look for the sides that we have or that we want. So we know the opposite side is x and the hypotenuse side is 12. And so, but then they didn't tell us anything about the adjacent. So the adjacent's kind of gone. We don't need to worry about it. So what trig function uses the opposite and hypotenuse side? That's sine. So we're going to use sine of theta is equal to opposite over hypotenuse. Okay, now that we know that, we're going to plug in all of the things that we want to know, or that we do know. So we'd say sine, but instead of theta, we're going to say 20, because that was what our theta is 20 degrees, is equal to opposite, which is your x, over hypotenuse, which is 12. Okay, so now we want to solve this for x. So to solve for x, we need to get rid of the 12. And the 12 right now is dividing the x. So to get rid of it, we have to do the opposite of dividing, which means we multiply each side by 12. And we end up with 12 times sine of 20 is equal to x. And now all we have to do is plug that into a calculator. Let me just grab mine out. So we do 12 times sine of 20, and we end up with x is equal to 4.1 approximately, 4.10. And that's our answer. Sweet. Okay. Let's go to the second example. So same thing. The first thing we're going to do is label our sides opposite, hypotenuse, and adjacent. They didn't give us a theta, but our theta is the 42 in this case because that's the only angle that they did give us. So this side is your opposite side because it's opposite of the 42. Your hypotenuse is always opposite of the right angle, and then your adjacent is the one that's left over. So they didn't tell us anything about hypotenuse, so that's out of the picture. We need to figure out what trig function uses opposite and adjacent, and that is tangent. So we're going to use the equation tangent theta is equal to opposite over adjacent. Now let's plug in everything we know. So we're going to say tangent of 42 degrees is equal to your opposite side, which is x, over your adjacent side, which is 20. Now we're going to solve that. To solve it, we need to get rid of the 20. The 20 is dividing the x, so to get rid of it, we multiply each side by 20. And we end up with 20 times tangent of 42 is equal to x, because these 20s cancel out. Notice that when I multiply, I always put it in front of the trig function. It's because we're not multiplying the 42 by 20. We're multiplying tangent of 42 by 20. And so sometimes if you put the 20 at the back of the equation, your calculator gets a little bit confused and doesn't understand whether you're trying to multiply the tangent by 20 or by 42. So make sure, this is just kind of like a calculator thing, make sure you always put it in the front. So now let's plug this into a calculator. 20 times tangent of 42, and I end up with the x is equal to 18.0. And there's my answer. Okay, awesome. Now, These other two examples are a little bit different, same setup and everything, but we're going to have to do something different at the end. So first step, we want to label our sides opposite, hypotenuse, and adjacent. So the opposite side is always opposite the angle that they give us. The hypotenuse is opposite of the right angle, and then the adjacent's the one that's left over. In this case, they didn't tell us anything about opposite, so we don't worry about that. We're looking for an equation that has adjacent and hypotenuse in it, which is cosine. So we're going to use the equation cosine of theta is equal to adjacent over hypotenuse. Now let's plug in everything we know. So it's going to be cosine of 36, because that's our angle, is equal to the adjacent side, which is 15 over the hypotenuse side, which is x. Okay, so now we're set up. We want to solve for x. But this time the x is on the bottom of the fraction. So when it's on the bottom of the fraction, unfortunately, we can't just divide by 15 because that would still leave x on the bottom of the fraction, and we don't like that. So instead, what we're going to do, there's this trick, and I'll show you how it works, but there's this trick that says we can take this whole side and switch it with x so that it becomes x is equal to 15 over cosine of 36. It's really just two steps in one, because what I could do is multiply each side by x to get rid of the fraction and then divide by cosine of 36. But if you remember this, you can make two steps into one step. So you take the whole left side, or whatever it's equal to, and flip-flop it with the x so that it becomes x is equal to 15 divided by cosine of 36. And now let's plug it into a calculator, and I end up with 18.54. So x is equal to 18.54, and there's my answer. All right, one more example. So first step, label our sides. Opposite, hypotenuse, and adjacent. So they give us information about opposite and adjacent, which means we're going to use the trig function tan. So tangent theta is equal to opposite over adjacent. We're going to plug in everything we know. So tangent of 34, because that's our angle, is equal to opposite, which is 10, adjacent over adjacent, which is x. Again, the x is on the bottom of the fraction, so we're going to take the entire left side and switch it with the x so that it becomes x is equal to 10 over tangent 34. All right, now let's plug that in to the calculator. And I get 14.83. So x is equal to 14.83. And there we have it. This is how we solve for sides using right triangle trigonometry.